for number 2, we're graphing 2b minus c. And so we're going to start off with this b vector. And so we are going to pick a starting point. It doesn't really matter where I begin to make my graph, but let's make it right there. I'm doing 2b. So if I'm doing 2b, I'm going to do 1b first. So that means I would go over 1, 2, 3 to the right. There's b. What do you think I do next? Draw another b. 1, 2, 3 to the right. There's 2b. And then I'm doing minus c. And so there's a graph of c right there. Anybody got a guess as to what we were going to do with a minus c? Grant? Yeah, good. And so he said do the exact opposite. And this is a little bit weird, but it's almost just like doing this. I'm taking that line that I have right here for C, and instead of doing this thing right here, I'm going to do the exact opposite, which is this guy. Okay, what Grant said was a great explanation. He said the initial graph of C went down 3 and right 1. If I want to graph the opposite of that, I'm going to go up 3 and left 1. And so my new graph is going to do this. I'm going up 3, 1, 2, 3, boom, left 1. This is C. And so my graph of what is the vector 2b minus c going to look like? This right there, that line, 2b minus c is the new vector that we get. It matters. Where did you start? Where did you end? You make sure you draw the arrow going from starting to ending point. Questions on that one? Try the last one with your neighbor. This thing. 1/2 a minus 2b plus c. If I wanted to graph that, Mackenzie, what do you think I'm going to start off by doing? I'm going to pick a point. I'm going to do what from that point? Yep. And so instead of going up 2, right 2, we're just doing half of that. And so she's going to go up 1, right 1. That is half of a. And so she just did half of it. We got that thing right there. Then we're going to do negative 2b. Allison, what do you think I'm going to do for negative 2b? Yep, 1, 2, 3, that's negative b, and she would do it again. 1, 2, 3, that's negative 2b. And then we're going to do plus c. So, Cole, what am I going to do to graph plus c?
You're going to go down 3 and over 1.
Oh, when you say over, which way?
From your graph, it's left.
We're going to go right with the same thing. Yeah, yeah. Okay, sure. I got you. You're good. Right there. There's my new graph. That line matches the C. This exact C that was drawn is that one. And so what is the vector 1/2 a minus 2b plus c? It is this line right there. So it took us a while to get there. I don't really care about which way it went, but my vector went down, left 1, 2, 3, 4, left 4, down 2. That is the resulting vector that came from that. Questions there? Let's look at notes. So not a ton of craziness. Again, it looks harder than it is. A lot of this stuff looks pretty strange, but it's not as bad as it seems. Again, the key to vectors is when we describe a vector. These happen in physics. These happen in computer science. These happen all the time. A vector has 2 main components. A vector has direction, and so we talk about left or down or up or right. Direction and what's the other thing? Magnitude. And magnitude is a fancy word that means distance or length or size or whatever else you want to call it. But they do use the word magnitude, as will we. But it's the distance of the line. How long is the line? All of these things we just talked about in bell work, but we can look at them again to do vector addition. This line right here is v plus w. They took v, they took w, and added them together. If that's positive v, negative v is just the vector going in the opposite direction. If this is 1v, 2v is just twice the amount. Negative v would just be coming back in one direction. Okay? And so given those 3 lines, v, w, and u, we're going to graph these 3 parts. Do that. You don't need me to do it for you. Take a second and go through those 3 again. W minus u. Carrington, what am I going to start off with to do w minus u? Yep, so what am I going to do? Down 2, right 2. That's W. And then you want to graph minus U. So what am I going to do to graph negative U? Over to the left one. Good. He's doing the exact opposite. Instead of going up and to the right, he's going down and to the left. That's his new vector. That part right there. And so his resulting graph is that guy. That pink line there is W minus U. That's what we're trying to get to. 2U. Yes, sir. Oh, unfreeze it. Yep. 2U plus 2W. If I'm graphing 2U plus 2W, Lester, what am I going to start off by doing? Up 3 over 1. Yep, so I'm going to start right here. 1, 2, 3 over 1. 1, 2, 3 over 1. Cool. That is 2U. Then what'd you do?
I did 2W.
So that means what? Down 2 over 2. And doing it twice because it's 2W. So that. And then another one of those. That line right there, that green line, is 2U plus 2W. Last one asks us to do V minus 2W minus U. Let's see what we can do with that one. Courtney, what'd you do to graph that thing? Okay. So you went up 2, right 3. Then what? Up 2, left 2. Up 2, left 2. Yep. Left 1, down 3. There we go. So we went here to there to there to there. But really all I care about is that final line. The actual answer to the graph, to the vector addition, is that thing. V minus 2W minus U would be that pink line right there. Questions with how we do vector addition? I kind of enjoy it. It's a little bit different. You just connect some dots. If V is a vector, we use this symbol. It looks like absolute value, but there's 2 lines. All right. The double absolute value, I don't have a great name for it, but that symbology right there, yeah, I might have made up a new word, to represent the magnitude. Okay. That's representing the magnitude. That's how long the line is. It is the distance between 2 points. A vector U, for which the magnitude of U is 1, is just called a unit vector. Just like we have a unit circle is a radius of 1, a unit vector is a magnitude of 1. And so magnitude is a simple concept. It's going to be really easy to deal with, even though it looks a little bit tougher. And so they are saying find the position vector in this first one. This is not magnitude related, but we can make it magnitude related in a little bit. Find the position vector. So we're going to eventually find the vector given those 2 bits of information. Let's do this by hand first, and then we'll show you what it looks like algebraically. So I'm going to have this, make a little XY graph. I need to be able to go left 3 and up 5. So here's an XY graph. For this graph, it's just ordered pairs. They are telling me the starting ordered pair is -3, 5. So I'm going to go left 1, 2, 3, 1, 2, 3, 4, 5. That dot right there is P1. P2 is this one, 1, 2, 3, 4, 5, 6, 7, and I went down 1, 2. That is P2. We are trying to write the vector that goes between those 2 things. A vector is just going to give us how far did you travel on the x-axis, how far did you travel on the y-axis. That is how we write this vector. So to get from here to there, to get from P1 to P2, how much did I need to move on the x-axis? Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I went to the right 10. And then I went down, so I went 10. And then I went down 1, 2, 3, 4, 5, 6, 7. I went down 7. Since I went down 7, guess what I'm going to do with that 7? It's a -7. That right there, 10, -7, is the vector that I traveled to get from P1 to P2. That is what our vector is going to be written with. this is how we're going to write the notation for this vector. We use these brackets right here. They look like greater than or less than signs. That represents the vector. Or in other words, it is some line. Okay? It is some vector that went right 10 and down 7. I don't care where it started and where it ended. All I want is the line, which is right 10, down 7. Does that make sense with how we drew that line? Okay? You could do it by graphing it. We just counted. Counting is easy. What could we have done with these ordered pairs to have found the vector algebraically? How could we have gotten 10 using those two points? Grant? Yes, it's like finding slope. Okay? He did x sub 2 minus x sub 1. So he took 7 minus negative 3. Guess what 7 minus negative 3 is? It's 10. Okay? We do the same thing. We find the distance, the difference between our y values. 5 and negative 2, we take negative 2 minus 5. Negative 2 minus 5 is negative 7. It is slope formula, basically. It's just your x's and your y's. Y sub 2 minus y sub 1. X sub 2 minus x sub 1. Those give us our values. Make sense on how we wrote that vector? Do the same thing on the second one. You can graph it. You can just do it algebraically. Just do it algebraically, though, because it's easier. Show me with your fingers, what is your x value going to be on this new vector? Show me with your fingers what your x value is going to be. Negative 3. We're taking negative 4 minus negative 1. Negative 4 minus negative 1, it's like plus 1. It gets me negative 3. So my vector is going to have an x value of negative 3. Show me with your fingers what's your y value going to be. You take 6 minus 2, you get 4. Boom. That's my vector. That's the resulting vector. You could have graphed it out and got the same thing. We did it by hand. That is one way of writing vector notation, is writing it with the absolute value, or not absolute value, but the inequality type brackets. You could also write it in this form right here. It looks really scary. It's super easy. All you're going to do is they say, let I be a vector with an x value, and let j be an x or be a vector with a y value only. If we wanted to take negative 10, 7 and write it in this alternate form of notation, it would look like this. 10i minus 7j. Basically, you write your x distance with the letter I, and you write your y distance with the letter j, and you put them together. It is the same thing as this. It is just another way of writing it. Write your notation for the other vector here. Negative 3, 4. Write that notation. Or write that vector with the alternate notation. So, Mara, what'd you write for that?
Negative 3i plus 4j.
Yep. Negative 3i plus 4j. Same difference. Make sense on what we're doing with that? Last class, we went to the backside. Let's look up here for a second. Let's go back to this adding vectors. So if I were to rewrite v, if I were to rewrite letter v right here as a vector, I don't care about starting point, ending point. I'm going to write it in that vector notation here. What would show me with your fingers, what would your v value be, or the x value be on your vector? How far did you go on the x-axis? Show me with your fingers. How far did you go on the x-axis? 3, and it was to the right, so it'd be a positive 3. Show me with your fingers, what would your y value be? 2. I went right 3, up 2. That is the vector. That's what this means. So looking at the next one, write your vector notation for that one. What would that look like algebraically? Show me with your fingers. What'd you get for that one? Show me your x value. 2. Is it positive or negative? It's positive because I'm going to the right, and my y value would be negative because I'm going down. And then my u vector right here would be this. It would be right 1, so it'd be 1, and my up 3, 1, 3. We can add vectors easier than drawing them out. So we drew it out for this first one. This answer, let's look at this letter C real quick, because we're going to show you this, and on the back side, it's going to make the back side super easy. That vector that we made, this whole thing, v minus 2w minus u, got me this vector. I went up 1, 2, 3. I'm sorry, x value first. I went left 2 and up 3, negative 2, 3. Everybody understand how I got that? We could have done vector addition just as easily by using numbers. And so if I wanted to do the v value, okay, I'm going to write my new vector by just doing it with the algebra using these three things. The v value. Oh, I started off with the number 3. And then I'm going to subtract from that 2 times the w. And so 2 times 2. And then I'm going to do the u value. So I'm going to subtract my u value. My u value is 1. So it's 3 minus 4 minus 1. Guess what you get? Negative 2. I just took the x values for each of these things and put them together just like it showed. That's where I'm getting this negative 2 from. I could do the same thing for my y. I know the answer is going to be 3. We drew it out. But if we didn't believe it, we could write it out as well. My u values, or I'm sorry, my y values, I'd start off with the 2 minus 2 times the w value, so it would be negative 2, minus my u1, which is 3. 2 plus 4 minus 3 gets me 3. Yep, it matches up. That's all we're doing with vector addition. Questions there? You guys are quiet today. Flip it over to the back side. So that's all this guy says is what we just did on the front side. Don't let that be scarier to you. They've given you 2 vectors here. They gave them to you in algebra here, or in numbers. There's the vector. It's the same thing as that. Here's w. It's the same as that. It doesn't matter which way they wrote it. Find these 3 things. Find v plus w, v minus w, and negative 4w. Find those 3 things real quick. Hannah, what'd you get for your x value on this first one? 9. Good. And your y value? 3. And she just took these 2 numbers, 9 or 3 plus 6 to get her 9, and 5 plus negative 2 to get you 3. If we were to draw it out, this is a graph of v. We went up 5, right 3. This is a graph of w. We went right 6 and down 2. Our resulting vector, this guy right here, is over 9, up 3. You can do it by pictures. You can do it algebraically. Let's look at the next one. V minus w. Irene, what'd you get for v minus w? Negative 3, 7. What'd you do to get negative 3? 3 minus 6, and your w, or your y value, sorry. 5 minus negative 2. 5 minus negative 2 gets you 7. Good. That's it. Don't make it tougher than that. Gracie, what about negative 4w? Negative 24, and what did you say? And 8. And what'd you do to get those numbers? Yep. Negative 4 times 6 and negative 2. She's just distributing that thing in to get her new numbers. Good. 3v minus w. Aisha, what'd you get for 3v minus w? 317. So you started off with a 3 times both of those. So it got you 915. And then you subtracted from that 6, negative 2. Ooh. Good. Last one, letter E is the double bar of W. What does that double bar again mean? Good. I'm glad you all said it in unison. The answer is magnitude. The double bar means the magnitude. Or in other words, what does magnitude mean? The distance, the length, the size, all of those things put together. All right, so we are finding the magnitude of W. So this is what W looks like. It's 6, negative 2. And so if you picked a starting point right here and went 1, 2, 3, 4, 5, 6, and down 2, this is a graph of W. Okay, that is the W vector. All I want from W is the magnitude. Or in other words, I want to know how far is it from that dot to that dot in a straight line. What could I do with this vector 6, negative 2 to find the distance from that dot to that dot? Pythagorean theorem. That's all we're going to do here. All right. Technically, it's distance formula, but it's even easier than that because they already told me the distance we had to travel on the x-axis, and they already told you the distance they had to travel on the y-axis. So we are doing x squared plus y squared equals r squared. It's the same concept that we were doing before. It's 6 squared plus negative 2 squared. Some of you kept on your test, took negative 2 squared and got a negative number. That's bad. Don't do that. That's 36 plus 4. It's 40. Make sure you simplify radicals. We're always simplifying radicals. I've never told you not to. If you were to simplify the square root of 40, what number would be on the, show me with your fingers, what number would be on the outside of the radical? 40 breaks into 4 and 10. 4 breaks into 2 and 2. 10 breaks into 2 and 5. And so my answer is 2 square root of 10. That right there, that is the magnitude of W. That is how wide or how long the W vector is. It's the magnitude. Questions on finding magnitude? The last thing is easy. The vector U equals V over the magnitude of V. That's just a unit vector. Remember what a unit vector was? That was just a line with a magnitude of 1. It was a vector with a magnitude of 1. A unit vector, this guy, when we take the vector and then divide by the magnitude, that is a unit vector that has the same direction as V. So if I had this line right here, and I'm just making one up. If that guy right there was my vector, the unit vector would be the line. Yeah, that's not a great draw of it. Probably something like that, which is going in the exact same direction. It has the same direction as it, but it's just a little guy. It's a unit vector, so its magnitude is only 1. So it wouldn't even go up a full box because I'm going at a diagonal. It would be over just a little bit. Kind of makes sense how that works? So find a unit vector in the same direction as this guy. So again, that's just a fancy way of writing the vector negative 5, 12. In order to find it, I'm taking the vector, which I have, and I'm going to divide by the magnitude. And so all I need to do to find the unit vector with direction is find the magnitude. How can I find the magnitude of negative 5, 12? Pythagorean theorem. Negative 5 squared plus 12 squared. 25 plus 144. 169. But I got to square root that thing. What is the magnitude of vector V? 13. And so if I want to write the unit vector with direction, all I am doing is rewriting that original vector, negative 5 and 12. The only difference now is I'm going to divide both numbers by 13. I'm dividing by my magnitude. If you took the time to take negative 5 over 13 squared plus 12 over 13 squared, guess what that's going to equal? It's going to equal 1. It's going to equal 1 because we said it was a unit vector. When you square root 1, it's going to get you a distance of 1. Questions on something we did there?